Over to you, Dr. Sanjay. Thank you. Hope I am audible. Audible to online also, online participants. So my session is on DNS attacks. Okay, so let us start directly because we don't have time now. This is the content of this particular session. We'll try to focus on what do you mean by DNS attack and what is the categories of DNS attacks which is there. So we have mainly two categories: attacks onto the DNS infrastructure, attacks onto the DNS servers, and so on. And second category says that saying that you can use DNS to attack others. So I have one picture image for you. You have to guess the person. Okay, you have to just guess the person. Yeah. So can you guess this person? Any of you? Have you seen this person? No. Okay. I'll tell you, this guy is Paul V. Petris. He is the father of DNS. So if we are talking about DNS, we should know who is the father of DNS. This guy has developed the entire DNS ecosystem, right? And we are talking about DNS, we should know what is DNS. So we all know, right? What is DNS? DNS do what? It does the IP address to domain name translation. Like we have our phone directory earlier. In that we have a name and the phone number, our landline number. Likewise, here also you have domain name for www.cdat.in. We should know what is the IP address of that domain name, right? So DNS is a service which will provide the lookup of the IP address to the domain name. So it does for both IPv4 as well as for IPv6, and it does the reverse also. What they mean by reverse? If you have the IP address, if you want to know the domain name, you can contact DNS and you'll get to know about that also. Now, if you talk about DNS, you have a lot of say components of DNS ecosystem, and you should know how DNS works also. How many of you knows about DNS working of DNS process? Can you raise your hands? How DNS works, sir? Knows. Okay. Few of them doesn't know. For them, I'll just have a quick. Yeah. Hello. Quickly, I'll just show you how the DNS works. So you see that if this is one of the system, this is your system at your home or at your office, right? On this system, you are typing one domain name called www.cdat.in. Okay, this is what you are typing here on your system. Now, what happens? All the system knows the IP address, right? Because they are following TCP/IP, where the network there, IP address has to be assigned. Okay, so for this, we need to know what is the IP address of cdat.in. Who will get to know? The client will get to know. Now, what is happening? How will client know the IP address of this particular domain name or this particular URL? Client will send a DNS query to your local DNS server. So you might be having your ISP has been provided one DNS server to you. So that query will be sent to your local DNS server, which is actually called as a recursive DNS server, right? So the IP address for this domain name, we are sending a DNS query saying that please tell me the IP address for this particular domain, okay, to this local DNS server, which is called recursive. Now this recursive DNS server will do what? It is because the DNS is very vast, very big, and it doesn't have the IP address of this. Suppose then what it will do? The local DNS server or recursive DNS server will send a DNS query to the root DNS server. It is called dot. Okay, it will be sent to the root DNS servers. And you see that we have around 13 root DNS servers across the globe, 13. And the replica are also there. For example, A root server. So 13 means what? A to M, right? A root server, B and C till M. So for each the root server, we have multiple replicas across the world. So in India also we have around 8 replicas, 8 to 10 replicas what we have here. So the recursive DNS server will send a query to root DNS server. Now, root DNS server will reply back saying that I don't know about www.cdat.in, but I know who can go and contact and ask, right? So it will reply saying that you can please ask in domain name server. Because in the URL, what I'm asking in is present. Root only knows about TLD, top level domain. In is what? It's called TLD, right? Now, what is happening in the DNS server of in domain, we got to know, this recursive server we got to know. Now, what recursive server do? It will send a DNS query to the in DNS server. This is called authoritative DNS server for in domain, in TLD. Now, again, in TLD will say that I really don't know the IP address of www.cdat.in, but I can tell you, you can go and ask one DNS called cdat.in, right? Because I know cdat.in. Please go and ask to cdat.in. So it will give a reply back to recursive DNS server saying that please go and ask to cdat.in, and this is the IP address for cdat.in's DNS server. Again, the recursive server will send a query to cdat.in DNS server asking the IP address for www.cdat.in, and in turn, finally, cdat.in has the IP address for this DNS server will have the IP address for www.cdat.in and will be providing to recursive DNS server. Now, what does this recursive DNS server do? Each recursive DNS server will have something called DNS cache, right? Every local DNS server will have something called DNS cache. So this recursive server will put this entry into the cache saying that for www.cdat.in, this is the IP address, right? Now, it is been cached here. And the same entry from the cache will be given back to the client. And client will get to know the IP address for cdat.in, and client will be able to browse that particular website. So this is how the DNS works. And in this DNS ecosystem, now we've got to know that we have something called recursive DNS server. So there can be attack on recursive DNS server. We have something called root DNS server. So there can be attack on root DNS servers. Then you have something called authoritative DNS servers. So with cdat.in, in, and all these are nothing, these are authoritative DNS servers. So we may have attack on authoritative DNS servers. And finally, you have something called DNS client. And attack can be there on the client also, right? So let us go back to the slides here. Yeah. So as I mentioned earlier, we have two categories of attacks. Number one category, if you talk about DNS attacks, number one category is what? Attacks onto the DNS infrastructure. So you are attacking directly onto DNS, attacking onto the root, attacking onto the recursive server, attacking onto the authoritative DNS servers. Yes, please. Yeah, tell me. No, see what is happening here. I am asking for cdat.in, www.cdat.in, right? It will be sending first to your recursive server. The client will send to the recursive server. Recursive server will send to the root. Root will reply with the TLD DNS server, which is nothing in here in that case. Then again, recursive server is going to in. Now, in will have a lot of records inside that cdat.in, ac.in, google.in, right? And like other organizations like .in. So all those records are there with TLD. Now TLD will say that you are asking about www.cdat.in. cdat.in somewhere is mentioned. So it will say that you can go and ask for cdat.in. You cannot go ac.in. Right? You will go to cdat.in and then I will give the reply. I hope this is clear.
So may I ask, so how long it will store the cache? I mean, talking about recursive resolver.
How you configure, sir? How you configure? In the configuration is mentioned that you can store cache for say 1 day, for 1 hour, for this is how you configure in DNS configuration.
Okay, so what is the recommended frequency to update the cache?
It depends on the organization. For example, I'll say that my cache entry should be more than say 1 day. Okay, so it depends on the organization. Maximum how long? 1 week you can store.
Okay.
Okay, let us continue now. So first category of attack is attacks onto the DNS infrastructure. So as I told you, attacks onto the root, attacks to the recursive servers, attacks to the authoritative DNS servers, and so on. So these are some of the list of attacks that are mentioned here, which we'll discuss now. So this diagram, if you see, we have one more category, attacks exploiting DNS infrastructure, that we'll see later. So if you talk about this diagram, this says that these are the list of attacks which can be there onto the DNS servers or onto the DNS ecosystem, where you have a root, where you have TLD, where you have authorized DNS servers, your client and recursive servers, and so on. So you have a attack on the client, which is called DNS ID spoofing. We'll discuss this. Then you have MITM, man in the middle attack, which can be on the client. And then on the recursive server, you may have attacks, which is called cache poisoning attack. Because as I told you, the recursive server will have some cache. NX domain is one more attack which can be there on recursive server, right? Even the DDoS attacks can be there on entire ecosystems. It can be there on recursive server, it can be there on master, slave, or root, and so on, right? And if you talk about this master and slave DNS servers, you know what is master, what is slave. So we are having redundancy in case one of the server fails, second server will actually serve the people. So in that case, we have master and slave. So slave will have the copy of the master, right? Now, there can be an attack on say master. Some people will spoof as a slave and download the zone data, or you can say database of the DNS servers, right? So that kind of attack is there. Again, you can have something called spoof updates, dynamic updates. I can update the entry of the DNS records dynamically, and then that can be spoofed, right? The IP address of that can be spoofed, and so on. So these are the list of attacks. Let us start discuss one by one. Now, first attack here, if you see, it is MITM, man in the middle attack, which is very much doable in LAN environment, right? So in this case, what is happening here? You are having one host here. This host or client wants to know the IP address of www.crack.in. Now it will send a DNS query to the recursive DNS server. Suppose this is what is a recursive DNS server. Now what is happening in between MITM attack? The person will reply on behalf of recursive DNS server, right? The person will reply on behalf of the recursive DNS server saying that I am the recursive DNS server and this is the entry, this is the IP address for www.crack.in. It is taken. The host will take and it will be redirected to some malicious website, because this MITM, this person is giving the wrong IP address, not the correct IP address, right? So this is one of the attacks which can happen in LAN environment. When a actual DNS server will reply, that will be discarded by the host, right? Or if it is MITM attack in between, because all the communication is happening through one attacker, that attacker may drop that reply which is coming from the DNS server. Okay. Now, second attack if you talk about is DNS ID spoofing. This will be applicable to the DNS clients. Okay, so you are the DNS clients, right? So this can be applicable to you all. Now, what is happening here in this case? The client will send a DNS query to a recursive DNS server, right? And you know that if you are using any DNS query, the query ID will be attached to that query. A uniquely identified query ID will be attached to each query, right? Suppose from your system 4 or 5 DNS queries has been sent. The DNS server should know, or the reply should know that, okay, this reply is for this particular query. So that's why to uniquely identify the query, if we have a query ID, a 16-bit query ID is there. Now, what is happening? The attacker will be able to get the query ID. If suppose in between attacker will see that, okay, you are sending a DNS query and this is the query ID, and it will be going to DNS server. This query ID, it will take and reply to the host saying that this is your reply. This is the IP address of your www.cdac.in. So with this query ID, it will reply the same query ID. So the challenge of the attacker is what we should know what is the query ID which client has sent. Okay, so there are methods using that they can get to know the query ID. Now, I told you that you can connect this now. Change there. Huh? Is it changed there? You connect it there, this particular cable. See what has happened, I joined remotely, so I have the system because I had to show you one demo. So from that system, the presentation was shown, so it was a little delay. So what I do, I directly I will put here on the screen. I hope it's not clear. Sorry. Back. Now it's fast here, right? Yes, so we were discussing about IDX movie, that is done. Now let us discuss about DNS cache poisoning. Now, as I told you, this attack will be applicable to only recursive resolvers. So you have recursive resolver which will cache your replay which is coming from a root or authoritative DNS server. It will cache always. Now, what is happening in this cache poisoning attack? The attacker what it does, it want to actually poison the cache of the recursive server. Some fake record the person has to put here, the attacker has to put here. So how he will do? He will send a DNS query to the recursive DNS server. Okay, saying that I want to know the IPs for some domain name. Here we are mentioning www.cdr.in. Now, what is happening? This recursive server will try to look up this. Suppose it is not in the cache. Suppose it is not there, the cache is empty, or this entry is not there in the cache. Now, what is happening? This recursive server will query to root first, as we have seen earlier. Then it will contact to cdac.in, and then it will contact to in and then cdac.in, and so on. But meanwhile, what this attacker will do? Attacker will reply to this DNS server saying that I am the authoritative DNS server for cdac.in, and this is your reply. I am the authoritative DNS server for cdac.in, and this is your reply. So this recursive server will actually try to get that reply and cache that reply. The fake reply will be caching here on to its cache. So next subsequent request is actually coming from the cache only. So your internal, suppose you have some local DNS server which is serving your all the clients. For all those clients, for this particular domain name, it will be leading to some malicious website. Okay. So this is nothing, it's a cache poisoning attack. How to mitigate this attack, cache poisoning? If DNSSEC is applied, this attack is not applicable. Right? If DNSSEC is applied to this cdac.in domain, then this attack will not be applicable. Okay. And then we have one more attack on to the recursive DNS server. And this attack says that annex domain. Now, what do we mean by annex domain? For example, suppose if you are saying that you have one client. So you have one client here. And this client is connecting to this DNS server. This DNS server will have some cache. It will try to look for the record through root and the hierarchy, and then store the cache. Right? Suppose the client is asking one domain name which is not existing. Suppose some domain name it is asking which is not there in the world, right? Now what is happening? Again, for that domain name, suppose that is abc.abc something. For this domain, what is happening? The recursive server will try to get, and it will say that this domain is not there, and then recursive server will put this entry as annex domain in the cache. So in the cache, what it put? It say that abc.abc is not there. It is not there in the world. So this entry it will put in the cache so that in the subsequent someone else is asking for abc.abc, the same reply will be given back to the client. Right? But this can be targeted by the attacker. How it can be targeted? Now let us take one simple example here, which is mentioned in this slide. Now you see that I have the attacker's machine, and you see that attacker is keep sending the domain name which is not existing in the world. Suppose abcdef1.com, abcdef2.com, and so on. It is keep sending the queries to your recursive DNS server. Now, what is happening to your recursive DNS server? It will go to root and D8 in the hierarchy. It will get to know that that particular domain is not existing. So it will put one entry here for all those domains. So what is happening here? Your cache is actually getting filled. The DNS cache is getting filled with unwanted data. Right? The cache is getting filled with what? Unwanted data. So suppose the cache size is of say 100 MB, and what attacker can do, attacker will send huge number of those DNS queries so that this entire 100 NP can be occupied. So once it is occupied, the caching will not happen. DNS may malfunction. Right? DNS server may malfunction or it will be responding too slow. So this is a kind of DOS, denial of service attack onto the DNS server using something called NX domain attack. So I hope this is clear to you all.
So can we remove the particular entry from a cache at a particular moment if we wish to do so?
So we have seen the attacks on to the client, we have seen the attacks on the recursive server. Then attacks can be there on the root and authoritative DNS servers. So these are the attacks, DOS and DDoS attack, which we all know. What is DOS? Denial of service. A client or the attacker will send a huge numbers of queries to your DNS server. Okay, so what is happening? Those queries, if they are more, the legitimate user will actually feel some delay in the response because the DNS server will try to resolve the query which is sent by the attacker. Right, so there is a slow response, but this attack can be sophisticated now using DDoS. So attacker will have the control machines here with him. Right now, what attacker is doing? Sending one DNS queries to this zombie machine, and this in turn, this zombie machine will send all those queries to actually your DNS servers. Now, this DNS server, which is recursive or root or any other authoritative DNS server, will feel that he is getting huge number of traffic from different say IP addresses or genuine IP addresses, which is under control of the attacker. Right now, what is happening within no time? This entire bandwidth of this recursive DNS server or the any authoritative DNS server will be choked, and the genuine legitimate user will not be able to get the reply from the DNS server. So these kind of attacks are nothing is DOS attack, denial of service attack. Okay, so first category we have seen. First category is what? Attacks onto the DNS servers. So we have attacks onto the clients, attacks to the say recursive and then root and so on. Now, second category says that you are using DNS infrastructure to attack others. So this is called attacks exploiting DNS infrastructure. So we have a list of numbers of attack. I discuss one by one. Now, first attack is what is called DNS reflection and DNS amplification. Now, what do you mean by this? And how it happens? Now, reflection means what? Suppose we have one recursive DNS server, right, which is there in the world, and attacker will send one DNS query. So what should happen? Reply should come to attacker only, right? So if I am sending query, I will get the reply. But what attacker will do? Attacker will spoof the IP address of any victim. Any victim in the world. It will spoof the IP address saying that I am this target and this is my query. Okay, now what is happening? Once this is coming to DNS server will resolve that query and reply will not come back to attacker because the IP address was spoofed in the query, reply will actually go to the target. And target will get the unwanted traffic, which target was not looking for. Unnecessary traffic it got. So this is nothing, it's a phenomenon of reflection. So what attacker has to do? Only spoof the IP address of any target. Now this can be more sophisticated here if the attacker will use something called send me the response for all the records of a domain name. For example, Google.com. Google.com has a multiple subdomains, multiple records. So if I want to know all the records for Google.com in single query, the response will be bigger. Right? Earlier I was saying that I want to know the IP address for cdat.in. But here I say, give me the all records of Google.com. So Google.com may have say 200, 300 records. The reply will be so big here. So if the query is 1 byte, reply can be of 100 bytes. So this is the phenomenon of amplification. The reply is amplified here, right? So this is nothing, it's called DNS amplification attack, which will use the phenomenon of reflection. So I hope this is clear to you all. I'll show you one demo later of this reflection, but this is clear to you all, right? And how to mitigate? Can you tell me how to mitigate this? You cannot mitigate. This amplification attack cannot be mitigated. It cannot be mitigated. So we'll see the one demo here, that time we'll get to know. Now, third or second category of this attacks exploiting DNS infrastructure is called DNS tunneling attack. And it's very dangerous attack. Means we don't have any solution which will say that you can mitigate the DNS tunneling attack. So I'll take a typical example here. To understand this DNS tunneling attack, let us take one typical example. Okay, so this camera you can turn here on the screen. Now, if I go to the online participants, my screen is visible, the TV is visible, where I am just writing something to discuss this DNS tunneling. Now, what is this DNS tunneling? I'll take a typical example here. We have a BSF border force, we have armed forces because now they are saying that their network is very much protected. They are claiming that. And how they are saying? They'll say that okay, they have one local area network, LAN. Okay, they have a local area network where all their clients are connected, the systems are connected. These are the systems of LAN. And from this LAN, suppose one internet router is there between one firewall is running. So this is nothing, it's a firewall. And in the firewall, it's mentioned that you don't allow any traffic from your LAN. Nowhere. This is the typical scenario of organization, right? You say you have firewall, LAN will not be able to communicate to the internet world. So this is the internet world. Right? Now what is happening? You will say that this is one client here. Okay. Now in DNS tunneling attack, what will happen? Even though you are having firewall here, even though firewall is here, the attacker can get the information about this client. This can download any client file from the client, right? Or attacker can do CNC or C2C, command and control, means remotely access this client. Attacker remotely access this client using something called DNS tunneling attack. So how it will do, what it will do, let us just discuss here. Now suppose I have one DNS server which is running here in the world, somewhere in the world on the internet. So this is something called abc.com. This is the DNS server which is running somewhere on the internet, right? Which is under control of the hacker. Right? Which is under control of the hacker. Now hacker has to do what? He has to install here one malware. His task is what? He has to just install one malware. It is called DNS tunneling malware. So suppose if that malware is here, and suppose that malware is running here. Now, even though on the firewall you say deny all traffic, but sometimes you say that here suppose one system is there, only this system is having internet access. Right? Internet access, if this system is having, then for this you will allow the internet, right? But for all others, you will drop it. For this person, you will allow the internet. Or you will say that, okay, I will allow DNS queries only. Here, all the system can send DNS queries. If this is the scenario, let us see. All the systems can send DNS query, but they cannot browse internet. Other people cannot access this system because these systems are part of that. They don't have the public IP address. Even though if you don't have public IP address, attacker can do CLC, can take your system report, he can access your system report. So how it will do? So suppose here one malware is running on one of the client. It's a DNS malware. And this malware will do what? It will say that I want to connect to abc.com. So what is happening? It will go to this firewall. Firewall will say that DNS queries are allowed. People can do DNS queries. So it will be allowed here. Then that particular malware will be able to send DNS query to abc.com. Let's perfectly alright, right? And suppose I have a file here, XYZ, and the file content is what? It's a confidential file, and content is what? Suppose it's a password of your all organization, say big database server or whatever, some password, confidential passwords are there, 1, 2, 3, 4, then 5, 6, 7, 8. So see, these are list of passwords. So this is one of the confidential password file. Now hacker can exfiltrate this file to the attacker's machine. How it will do? Now, if the malware is running here, what this malware do? This malware will say that, tell me the IP address of 1234.abc.com. This query will be sent to the DNS server through firewall. So through firewall, this query will be sent there. Now, query will be received here. No, sorry. So what is happening here? 123 has come up to here. 123.abc.com. Means one password has come here.
The
Right?
screen
One
is not
confidential
visible.
file been opened
Sir?
by malware, and they have typed the first line and they added to that query, and that query is being sent here. Now this person got 1, 2, 3, 4. Then it
The
will
screen
replace agent,
screen
okay,
is
I
not
got that.
visible. Hello, sir. Screen is not visible.
Now again, what it will do? It will take the second
Hello,
line,
hello.
append it to the query 5678.abc.com. The same thing will be allowed here in the firewall. It will be allowed in firewall and it will be sent to here. Now the attacker got one more line of that. So likewise, entire file can be exfiltrated to the attacker's machine. Very, very dangerous. Right? Even though you are saying that you are protected here, nobody can download, nobody can upload, but I can upload a file from this system to the other system using simple DNS queries and responses. Process will be so slow. Suppose here this file of say 1 MB, 1 MB may take say half an hour. But your confidential file can be exfiltrated to the attack machine in that half an hour. So this is the phenomena, this is the concept of DNS tunneling. You are tunneling the other traffic inside the DNS queries and responses. This is the meaning of tunneling. You are carrying other traffic. So what traffic I am carrying? I am not carrying any traffic. So I am just uploading the file. So FTP server. So FTP server is running inside the DNS server. It is used inside the DNS server.
अगर DNS उसके भी हो सकता है क्या?
अभी हम DNS की बात कर रहे हैं सर, तो DNS से तो हो सकता है definitely. I'll show you one demo also. The demo is ready, right? I'll show you the demo also. DNS से तो हो सकता है. DNS के बगैर अभी देखना पड़ेगा कुछ और मेथड है, right? So I hope this is clear to you all. This is clear, right? Okay, I'll show you a quick demo on this DNS tunneling attack. Then we'll again see a demo on DNS amplification attack. So change it. Okay, so what I have is two systems here. If I open MS Paint here, so that online people also can see. So I'll be having two systems here. This is one system, okay, and this is the second system. This second system is nothing, is one DNS server, right? It's a DNS server which is under control of attacker. Right now, this first system is a system, normal system, which will send the DNS queries, right? Which will send the DNS queries. Now, in between, there is a firewall which is there, and in this firewall, it is mentioned that deny all. Deny all. Before that, it is mentioned that allow DNS queries. Allow DNS queries and deny all. So what is the meaning of this? All other traffic will be denied. Only DNS queries are allowed. Only DNS queries are allowed. Other things will be denied. Now, in this case, what is happening? On this client machine or any system attack or target system, we'll say this is target system. This is the target system. So on this target system, I'll be running one malware called DNS Cat2. So this is the malware which I am running on target system. Okay, and this DNS server, which is under control of attacker, is also running DNS Cat2 service. This is the service, that is the malware. Right? And then what I will do, I will try to, here I will be having one file. Suppose abc.txt file is there. This file we will create it on the client. And this file can be downloaded to this machine using this particular setup. So this setup is clear to you all. So we say that we have one system where one malware is installed, this is called DNS Cat2. Then we have one server which is under control of the attacker, where the DNS Cat2 is running, a service is running, and in between a firewall is there, which will block all the traffic, only allow DNS queries. Right? So this is the setup. Now for this setup, I tell you this is my DNS client here. So DNS server, let us be say this is the attacker's machine. So this is the attacker's machine. On this attacker machine, DNS Cat2 service is running. And if you see this IP address of this attacker's machine is 4.102 is the IP address of attacker's machine. Okay, and then I have one system where this malware is running, DNS Cat malware. Okay, so here you see this is the IP address of say client machine. The same thing we'll try to put it here on this pane here. So the IP address of this is 192.168.4.101 and the IP address of this is 192.168.4.102. Okay, this is the IP address. And currently let us see on the client what firewall is running. So on this client machine, if you see, I'll say IP tables minus NL. No firewall is there currently. No firewall, right? It says accept. Means it's IP tables firewall which says that currently everything is accepted. So if it is accepted, then I can ping 192.168.4.102 is the attacker machine. I can ping, right? So you see that I am able to ping. Done? Okay. Even if you see here, I can on the client only, I'll be able to browse internet. So this is the internet which is accessible on the client. Now what I want this setup. So in that, I have disabled everything onto the client. This, I have to say, this firewall, I'll say disable all, allow only DNS queries. So how do I disable all? I'll add some firewall rules inside that. So I will add one firewall rules. I'll say IP tables input drop incoming connection. Drop all the incoming connection. Again, I'll say IP tables policy output. I'll say drop. Outgoing connection also please drop. Okay. So both incoming and outgoing connection I have dropped it. So if I am dropping it, now I say if I want to ping that IP address, will it allow me? No. No. So you see that ping is denied. Means firewall is active. Firewall is active. Same thing if I try to browse also, it will say I will not be able to browse now. Why? Because my firewall is dropping all the packets, outgoing and incoming. See, it is not going. It's just rotating, trying to connect to the Google website. Okay. So now this client is at the safer side. And this is what is there in our BSF. Suppose let us take the example of BSF. This is there in the BSF. Now on the firewall, you have done some configuration saying that allow only DNS. Now let me allow DNS. I have dropped on. I'll allow only DNS. So DNS outgoing and incoming I allow. Right? The DNS query outgoing and incoming DNS queries I allow. So let us do that on the client. Again, if I go back to the client here, I'll say IP tables append, right? Input minus P UDP. DNS uses UDP, right? Minus, I'll say output. So before that, I'll show you, before applying this rules, I'll say incoming outgoing is dropped. I will try to do DNS queries. NS lookup is what? It will send a DNS query to some DNS server. So I'll try to send to a DNS, our main DNS server, one query I'm sending. Will it allow now? It will not allow because incoming, outgoing, everything is dropped. So it will say, I am not able to send a DNS query to google.com. You see, it is doing only, it will not allow you to send the query. Right? Let's keep connecting and somewhere it will show that it is not allowed. Okay, so currently it is not allowed. If I want to allow, you see, no DNS server to this is the reply which I got it. Now I will add a firewall rule in IP tables. I'll say for outgoing connection, DNS you allow. Right? Outgoing connection, DNS you allow. So I'll say IP tables minus A output. Then I will say minus P UDP. DNS uses UDP. And then say minus D port 53. So DNS will use UDP port number 53. So outgoing port number 53 is allowed now, minus J accept. So this is one rule I added here, which says that outgoing DNS query will be allowed. I'll say enter. So this rule is added. Now again, if I see my IP tables here, so sorry. You see that one rule is added, outgoing. So if I send a DNS query, I'll get a response. Suppose if I'm sending a DNS query, I should get a response, but response incoming it is by default drop. So incoming DNS also should be allowed in this case. The response should be allowed, right? So what I will do here, again I'll add one more rule here. IP tables, append in input, I'll say, and minus P UDP minus S port 53 minus J accept. If anybody is giving me the reply from port number 53, please accept. DNS reply if I'm getting, please accept. So these two rules I added, only related to DNS, right? If I say again IP tables minus NL, you see these two rules only are there. These two rules are only there. Okay, one outgoing DNS, incoming DNS. And now, still I'll see whether I'll be able to ping that system or not. 4.102, the other side, I try to ping that DNS server. See, ping is not allowed. But if I say NS lookup www.google.com, you see that I am getting DNS responses. Right? So this setup which I wanted, it is now there with me. This setup which I wanted, it is there with me. So in this system, I am having this firewall which is running and outgoing everything is denied, only DNS queries are allowed. Okay. Now, if this is the setup, what can I do now? So here, I am already running one DNS cat service onto the attacker's machine. So this is the DNS cat service which is running here currently onto the attacker's machine. This is DNS cat service. And then onto the client side, I have to execute that malware. So at the client side, this side, I have to execute this malware, DNS cat to malware. So if it execute from here to here, communication can happen through DNS queries and responses. So let us now execute that malware on the client side. So how do I execute that malware? I will just say that /DNS cat minus DNS server is equal to 4.102.168 port 53. So this is the command which I executed here. What it says that this is the malware which is trying to connect to that DNS server over port number 53. And it will connect. Why? Because DNS queries are allowed. Okay, if I say enter, 1 minute. Here is equal to was missing. Sorry, the is equal to was missing. Now you see that it is connected. Session established means what? I can actually do whatever I want between this server and this client. Means this is the attacker's machine. This is the client. One session through DNS tunneling is established. Now what I will do? I will have one file here abc.txt, which I want to exfiltrate to this particular system. I have a file called abc.txt. So let us create this file here on the client machine. So one session is established, and then I will create one file abc.txt, or any file name will say, right? We'll say, sir, what's your name? Huh? F-A-Y-Z.txt. This is the file name. Okay. Hello, this is for demo, right? This is very confidential file. Okay, this is what I am writing in that particular file. So this may be the confidential file, which is sitting where at the client side, where the malware is done. Now, from the server side, I am now sitting on the server. Session is established. I see here there is one session which is there. So I am sitting now at the attacker's machine. I want to remotely control that machine, right? So I am sitting now at attacker's machine. This is attacker's machine. I am saying that one session is established. One number one is one session. So I use this session. Now I am into that session. Okay, I am into that session. Now if you see, I can do what? These many things I can do. I can download a file. So I'll say download. What was the file name? So I don't know what is the file name. Suppose attacker don't know the file name. What attacker will do? Attacker will open a shell between my system, attacker system, to the client, the compromised client. A shell will be created, remote shell. So I'll execute this command shell. Right now, here one more shell session is created. I'll say I'll use this shell session. Right, this is shell session. I'll say ls. ls command is giving me the output. And here prs.txt is one file. I got to know this is the confidential file. ls command which I am executing here on the on attacker's machine, which is getting executed there at the client, output is given back to me. So entire shell is with me, CNC or C2C, command and control. I can control that particular system. So I got to know what? I got to know the file name. If I want to see the content, I can see the content also. So see, this is the content of that file. Where I am seeing on the attacker's machine. Even though firewall is there, you see firewall, it says DNS all. So I am talking about, sir, BSF. If you say that this is your entire network is private network, no internet is there, but still somewhere router is there, and on that router somewhere you are written in the firewall that allow DNS queries. Still people will be able to access your system remotely. Very, very dangerous. Right? Now, okay, let me download this file, abc.txt. Okay, so how do we download here? I got to know the file name, prs.txt. And then what I will do, I'll exit from this shell and again let me download. So this shell is exited. Again, I will say window -i1, and then I'll say download as YA. Right? What was the name? I am typing this command onto the server, means attacker's machine only. Now you see the file will be getting downloaded. See, wrote 55 bytes. So I'll go to server here and I'll see whether that file I got or not. You see fires.text I got text dot I got it. So I'll say cat fires.text and see the same content of the file I got it given. Even though I have a firewall, the file can be data can be exfiltrated from one system to other system. And even entire command and control means your system can be remotely accessible by the user. What attacker has to do? Somehow he has to push one malware to your machine. So आपके DIG बैठते हैं वहां पे, उनका सिस्टम बोलते बहुत प्रोटेक्टेड है, बट उसमें आप देखते हो कि दो नेटवर्क आते हैं उसमें, एक लैन में जाता है, एक इंटरनेट पे भी जाता है, तो उसमें ऐसा हो सकता है, they can do that. Now what this is clear, right? What is DNS tunneling? How it can be done? Very easily it can be done. The only challenge for the attacker is to drop a malware to the target machine. If he is successfully able to drop, even though firewall is there, even though you have UTM and all, still this attack will not be detected. Still this attack will not be able to detect it. Right? So let us move back to slides here. So I hope this particular attack is clear to you all. DNS tunneling attack. Any question here? No question. It's clear. How to mitigate? This is the biggest the question.
Firewall can be changed.
What you will do change? DNS should not be query should not be allowed in case if you are having the separate. But if you see normal IT network, always they want internet. Normal IT network, always you allow DNS queries, right? So in that case, you cannot mitigate this. In that case, you will not mitigate this. This IT network, you have to allow DNS queries. Then only your internet will be browsable. Otherwise, you will not be able to browse. So there you cannot mitigate. But in your isolated network, disable DNS, then it can be.
How are the domain names? What kind of domain names get connected to the CNC in this case?
Any domain name. Any domain name. That's what attacker will have a domain name called abc.com, which is the genuine. Which is what genuine. Right? So I have created for that setup also, internet setup also, where I have used a domain called coe.dnssecurity.in. Your website name. I use that domain name for DNS domain. And from outside, I can exfiltrate the files to that particular server where the DNS server is running, DNS cat is running. So for this attack, we have a lot of tools. I'll just tell you those two names. These are the tools. We have just seen DNS cat 2. We have iodine. One of the best tool for DNS tunneling is iodine. Right? Then DNS cat 2 also is there. Then DNS 2 TCP, Ozyman DNS. There are so many tools are there. So my research work was this only: how to detect this DNS tunneling. So somehow I achieved something. I said that if you are using iodine, this is the method. If you are using DNS cat 2, this is the method. If you are using DNS 2 TCP, this is the method. So I have developed the tool specific IDS signature. In my research work, tool specific IDS signature I have developed. And I said that I have at least almost 10 tools. For those 10 tools, I have successfully developed the IDS signatures. And those IDS signatures will be able to identify if you are using DNS cat 2, it's a this is tunneling attack through cat 2, which is happening now. Right? But if you have a new tool, then still you don't have any solution. So again, one signature you do. Okay, so I give you one more example here. I hope we have time, Gopi. Good, thank you. Yes.
There are malwares you have antivirus and malware protector and
You might have seen this malware is only sending DNS queries. It is not related to some antivirus signature, which is slowing your system or which is trying to get some data and all. It will only access your storage. That's all. Yes. So here this malware will do what? It will send the DNS queries. So read your file and send there.
It is based on DNS.
Yeah, definitely. Okay, so one more attack. So this is the second category. Attack exploiting DNS infrastructures. So in that DNS tunneling attack you see, we have one more attack called DNS reflection, which I showed you earlier. This is DNS reflection. So let us try to demonstrate how this DNS reflection can be done on LAN environment. It can be done on WAN also. LAN. So in LAN, what I do? I will be having a DNS server running somewhere onto the internet. Okay. And I will spoof the IP address of one of your systems and send the DNS query to the internet DNS server. Now reply will go to you, and you will see in your Wireshark or TCP dump that one unwanted reply is coming to you. So I can amplify also here. I'll ask for google.com all the records. You will be getting. I will be sending a 1 byte query. You will be getting 100 bytes reply, big reply, 100 times bigger. Right? So that we can see. Now I'll show you the demo now. DNS amplification attack. Again, for this, what I have, this is what I am having. It's called DNS It's a file which is available on internet. It is for DNS amplification attack, DNS I'll just show you on internet at GitHub. This will be available. I say DNS GitHub. So this file is available. It's a simple C file. It's a C program. Okay. So you can see this is the program here. And if you see this program, how to इसको minimize करके how to minimize this? I have to open that tab. Yeah, open here only. And you see, this is the program. It's, I guess, some 200-300 line program. Okay, this is 500 line program, right? 660. So this is the program which I'm going to use here. So this program already I downloaded on one of my system. This is the system where this program I downloaded, and I compiled that program. Okay, you see, program is you have to compile it. I compiled it. So once I compiled, you see that I got one say output object file, right? Executable file. It's an executable file, right? So now if I want to execute this file, what I'll say, this is the help it will show how to execute this command. Now to understand this amplification, what I will do here, I will open one more page. Now here I'll say that I'll be having one list with me, right? This is the DNS server list. So you have public DNS servers 8.8.8.8. It's a public DNS server. Sir, NIC has one DNS server. One dot 10.10.10. This is NIC's DNS server. Huh? Open DNS. Good, sir. So these two DNS I am using. And we have 4.4.4. here, and here even we have our own DNS server. What is the IP here? Huh? Okay. What is the IP? You don't know? What is it? 120, 120, I know. The starting two IP of this number. Okay, leave it. You tell me later. So these are the list of DNS server the attacker should has. Right? Attacker is having. And attacker has this machine where this DNS DR DOS program is running. Okay? And then we have one target. So this is the target machine. So suppose target machine IP address is, suppose I write the IP address of say my own machine. So I'll see what is the IP address of my machine here. If I see, I'll get to know. I can use here also, no issue at all. But to show them how it's working, I'll use mine. 4.103 is my machine, means my Windows machine. It's a Windows machine. So I'll write this 192.168.4.103. Okay, and this attacker's machine IP address is 192.168.4.102 or one whatever. Okay, now what is happening? I should have this list of DNS servers. The query will be sent to these DNS servers, right? Spoofing the IP address of visiting machine. So from this system using DNS.c, the query will be sent here, but this reply from them will come to the target machine, right? And target will get the unwanted one. So this is the setup which I'm going to achieve. Okay. So I have this machine with me where DNS here DOS.c is there with me. I just open that machine, and in that machine only I have the list of the DNS server. I'll say list dot text. So in that I will say a dot. This is plain. No, I want server. This. Yeah. So here, if I say one list I'll create, I have written a.a.a.a.8, 1.10.10.10. Okay, this two IP address I mentioned, and I'm saving it. Okay, this is available with the attacker system, and in the attacker system, I'll say DOS attack help if I see, and then I'll say DOS attack minus f. This is the file. Okay, and then I will say minus s, I guess, spoof the IP address. Which IP address I have to spoof? 192.168 and then 4.103. Just let me confirm here the same IP address on the system. Yeah, correct. And then I'll use the domain name the google.com and loop this query for 1010. Means 1000 request will be sent to a.a.a.a and 1.10.10.10. Reply will go to the Windows machine from 8.8.8.8 and 1.10.10. So those 1000 replies will come here. So if I will check here, I'll open on my system Wireshark. Okay, so I want to check on my machine where the Windows target machine, Wireshark I open and see what DNS traffic is going there. Okay, so I use Ethernet device, the Ethernet, and I just filter for DNS only. Okay, and you see what is happening. If I send this command here, it is sending queries, reply will come to CV. 1.10.10.10 is replying to that machine. So this is the reflection which is happening. Amplified reflection. So like that, any internet resources can be targeted. Right? So if you're having any internet resources, their unwanted traffic will come from the DNS servers. But your firewall will see it's a reply, it's simple reply, it's allowed. Your firewall will allow, right? And then there may be a denial of service attack on your network. Because your network can be shown with this kind of unwanted traffic. Right? So this is clear, DNS amplification attack. Is it clear? Any question, any query? Okay, so let us go back to slides. No queries are there. Yeah. That's what mitigation will do now.
That's a big question mark.
It's a big question mark, obviously. Obviously, some people say that some security industry they say that we have solution which is called DNS firewall. DNS firewall secure DNS they are protecting their say organization using this particular appliance or device, right? But that is not a foolproof. If I will have one small say malware which will only send very small DNS queries to the DNS servers, reading your data and sending very slow, that the guy will not be able to detect. Right? So normally this kind of DNS cat and all, they will take 1 hour for 1 MB file to download or 1 GB file 2 hours. But in that case, I'll say full 1 day I'll take for 1 MB file. Very slowly I'll do. I'll wait again, I'll copy, copy. Still it will be exfiltrated. They will not be able to detect. They will not be able to detect at all.
People who are running a complicated domain, like organization having their own DNS server, and resolving the domain outside. It's a big risk for them on this thing.
Yeah. The appliances are there, DDoS appliances like DOS attack. If you have more traffic which is coming, they will say that you block those traffic. From same IP, more traffic is coming. But sir, okay, so this is all about this session. Hijacking is nothing. Any client can be targeted to this particular attack called DNS hijacking. In hijacking, what they will do, they will install a malware on the target machine like clients, normal clients like your system. And what that malware will do, it will only change the TCP/IP settings of your computer system, and they will change your DNS to their DNS. Right? So your DNS will be your ISP DNS, or you might be using 8.8.8 or 1.10.10.8. They will change it and they will write their DNS entry there, and you will be misleading to some malicious websites. So this is called hijacking, DNS hijacking. So there are so many malwares which are there which will change the TCP/IP settings. So this is all about this session. What is written here? A successful DNS system is like oxygen. Everyone takes it for granted until it disappears. So this is what is the mock practice is telling, that you should secure your DNS infrastructure and you should keep monitoring your DNS infrastructure. Thank you very much. Any question? Thank you, sir. Thank you, sir. Any questions? Online participants, any questions? Let's check chats.
Stop sharing.
So how to host a local DNS server? Someone is asking how to host a local DNS server. Bind you can install, and there are only few steps. You say if you're using say Linux Ubuntu, you say apt get install bind. That's all.